Yeah, sure. That's completely fine. You can totally do that. Being here is optional anyway, so yeah. If you want to do something else, you can. And if you do want to play, you can. Only 2 people so far? Come on. More people than that. Yeah, for the most part, we're just gonna be doing the Kahoot. I have a couple other questions, like from the review I made, or we made, there are a couple other questions that aren't in the Kahoot that we're gonna go over, but today's just a review. So it's gonna be mostly Kahoot, and then we're gonna go over the other questions, and that's it. That's the plan anyway. I mean, obviously, like, if you guys have questions, we can totally go over this as well. Like, there's a topic that you guys aren't very clear on, we can work on that. Yeah, okay. If you need to work on the project, that's okay. All right, well, then it looks like just about everyone's here, so I think I'm going to start it. Well, not everyone's here, but I mean, like, everyone who's here is in the game. So let's go ahead and start the game. Yeah, hopefully it'll be fun. All right. Yeah, everybody on the leaderboard, that's true. That's a good thing. Awesome. Yeah, cool. So, right. Um, if you guys remember, most weeks, like I'll end up when I write code, right, I'll have to use these commands anyway. So yeah, if you remember it, it's Java C to compile. So it's Java C file.java, and then the next line is just Java file. So this runs it. The first one compiles, second one runs it. So I have to put Java C first with the name, followed by Java, and yeah. Second one's just Java file. Okay. So yeah, that's just how we compile using command line. And if you're just getting here, you can totally join this game. It's not too late. Game pin down here. Okay, next question. Wow, everybody's on the leaderboard so far. That's crazy. Yeah, awesome. Yeah, it's a driver. For input, I mean, I guess technically like, input output is one, but yeah. So right, driver is not processor, storage, memory, input, output are all examples. Okay, cool. More people. Nice. Yeah. Okay. Cool. Right. So for multi-select, yeah. So let me see. Right. So, this is kind of a tricky question. So yeah, it's line 5 because 1, 2, 3, 4, 5. This one doesn't have a variable type, right? We didn't say like int var3 equals 4. So that's why line 5 is a problem. Line 7 is a problem. Does anyone know why this one is a problem? Anyone have any guesses? Why this might be a problem now that you know it's wrong?
Because the variable starts with a 1.
Yes, that's right. Exactly. Very good. Right. So remember,
I mean, I
variable
still
names
got it
can't
wrong,
start with
so.
a numeric. It's okay. Like as long as you realize it now and like you know to look for it in the future. So yeah. And then this one, right? It's because like this is not how it like equals in Java means like assignment, right? So we can't assign 0 to var4 minus 10. That just doesn't really make sense. So we can't do that, right? So those are our issues. Okay. Any questions about anything? Oh, also, yeah, actually, this is a good one. Why is this one not a problem? Like assuming first letter's okay. Like because when we rewrote it, it's like one letter or something. Yeah, exactly. That's right. ASCII values, because ASCII values, right? ASCII value, like every char really has an ASCII value, right? So this A has a numeric value, because the chars are just numbers. It's like 0 to 127. So first letter is still a number, so we can still add 1 to it and assign it to a char because the char is still a number. Good, cool. Cool. Yeah, 79. So this one's just one that takes time. But yeah. 6 times 13.5 minus 8.5. Yeah. So anyway, like yeah, just takes time to do. But like if any of you have questions on any of these questions, like as I'm going over them, just stop me, let me know, and then I can go over more detail. Also, for anyone who's like joined recently, like game pin down here, so you can join. So cool. Yeah, so it's true because for an and, right, both conditions have to be true. X mod 2 is 0, right? And that's clearly true, right? Because like 6 is divisible by 2. So because 6 is divisible by 2, it's equal to 0, right? 6 mod 2 is equal to 0. Oh, yeah, that kind of sucks, right? I don't know, Hayden. And y is not greater than x. Well, this is saying like y is greater than x, but not that. So it's saying it's like not 5 is greater than 6, which also true, right? Because it's not true. So yeah, that's why var is true. Wow, nice job, Zane. Yeah, I have the slides actually that these came from, and there are more questions than just the Kahoot has, so I'll post all of it later. I'll just like put it in a Google Doc so everyone can see it, because I know people have had trouble accessing PowerPoints in the past. Okay, so are there only 8 people still playing? I guess so. So in the future, if we get to 8, I'll just skip. So yeah, it's false, right? Because for an or statement, they both have to be false, right? And so yeah, this is false because x minus y is 5, which isn't less than 0. And y is not less than 0, it's 7, right? So yeah. Okay, cool. Wow. Zane, you're on a roll. Awesome. Yeah, you got that right. So nice job. So right, it's because if just one of them is true, the whole thing is true. And the second one is true. So very good. Yeah, awesome. Cool. Yep. And then you have to remember, like, sometimes the trick on these questions, because I know it might take time if you work through it all right. Sometimes the trick is just to look at the pattern, right? And the pattern here is like every time it's divisible by 2, we just don't add it, right? Because we don't get to this line. But if it isn't divisible by 2, we add it. So we're only adding the odd numbers, right? So we're only adding like the odd numbers of 10, which is 1, 3, 5, 7, and 9. Yeah. Yeah. We'll go through everything. Yeah, we're gonna get to up to the last module. So yeah, everything is in there. And I know the last module we didn't really have time to go over it, so we can spend a little bit longer on that one today because I know like well, we didn't really go over that in discussion, right? So yeah, when we get to that part, we can talk a little bit more. Yeah. Yeah, I know there wasn't a whole lot of time to do this problem. So I guess that makes it kind of tricky. But yeah, hopefully you guys kind of see, right? They're like, for example, just looking at this one and this one compared against each other, you can quickly see like, oh, these aren't the same, right? Because this first part here is 7, and this is 8. And we can do that because like we start from the right? Like that's 1 and that's 7, and that's 8 and 1, right? So like right off the bat, we know one of these isn't the same as the others. And then we can just look and we're like, oh, okay, well, that's 8 by 16 is 112, I guess, yeah. Or not 112, sorry. It's larger than that. I was trying to see like this, but no, it's not. Because it's 48 plus 80, which is 128, so like 129, which isn't the same, right? It's like 113 basically. Okay. Yeah, no, that problem was like tough. Cool. Yeah, that's right. So that one's not the same as the rest. And like just like before, we can kind of look, we can see, oh, this isn't the same as the previous one because like, or the space 16 one, means I could take the first 4, right? And they total 10, which is still A. Then this is 3. So we have 3A, this is 2A. So these aren't the same. And then we can kind of decide, okay, which one is it? Maybe we can convert this one to base 8. Like base 8, we can check. We can be like, oh, well, that's like 2, right? And that's 7. Yeah, and that's like 52. Right. Cool. Wow, enter. That's a lot in a row. Way to go. Oh yeah, so this problem, I'm so sorry. I just remembered. Yeah, this problem, you know what? No one's answered, so we're just gonna skip. Yeah. And the reason we're gonna skip is because like the answer choices aren't right here. You guys can do it, but like it's supposed to be, this add isn't supposed to concatenate. it's supposed to actually just print the sum. So none of the answers are right. So I'm just gonna skip it. I just remembered, yeah. But we can walk through it really quickly. It's just gonna be, right, it makes a new student of, actually, you know what? If you guys wanna, I'll walk you through it because like it might just be a little bit annoying to do. So I'll just go through it quickly. Like it might not annoying to do in hard, as in hard, just like might take a minute. So we create a new student, right? Bob of grades 1. Grades 1 is 85, so he has grade 85, right? We set grade X to grades 2, so this is going to be 90, right? Oh wait, not grades 1 is 80. Sorry, I don't know why I said that. So it's 80, then 90. Then we pass in grades. So that's this array, right? We pass in Bob, so we pass in student Bob, and we pass in grade X, right? And grade X here is grades 2, so that's just 90. So we pass in 90, Bob, and our array, right? So the same as grades. And then the trick is that here, to position 0 in our array, we're adding 25. So when we add 25 to 85, that gives us 110. Student.grade set to 100, right? And then grade equals 101. But remember that student and arrays are both reference types. So when we pass them into a method, it actually, you can change the value. But for ints, that's not the case, right? So when we do this, we're actually changing grade 0 everywhere in the program. So this grade 0 is actually changed. We actually change student's grade because it's reference type, but grade we don't change in this method, right? Because it's just an int, it's a primitive. And primitives we don't change inside of methods. It like creates a copy when it passes, okay? So then we end up with just like adding these 3 with grade X changed, grade X is unchanged, sorry. So that one's 90, this is 100, and this is 110. So we get 300. Okay, so that makes sense to everyone? Cool. If so, like thumbs up. If not, then like, oh no. Cool, thumbs up, glad to see. Awesome. Yeah, let's go. Okay, cool. Yeah, so I'm sorry if I kill anyone's streak. I didn't mean to do that. It's just the answer's wrong. So sorry about that. I know, Endrick, you're on a really long streak, so sorry. Huh. Would you look at that? It looks like code that I wrote. But yeah. Okay, yeah. Right. It's 1, right? Not 11. Because remember, primitives are, well, primitives, right? So an int is a primitive data type. So it's not a reference type. So when we pass it into a method, like when we pass it into add 10, right here, right? It's passing a copy. It's not actually passing the same variable. So when we pass 1, it's a different 1. It's a different, like num is, this is a different num because int is like a primitive. So for ints, chars, doubles, strings, but that's for a different reason. But it's because strings are immutable. So like if you pass an int, char, double, string, float, like any of those into a method, right? Anything that's not like a custom object or an array, and you change it inside of that method, then it's not going to change the original one. So it won't change num here. This is a different num, okay? Does that make sense? Why it's like, why it didn't change num here, so it's still 1 right here. Cool. Yeah, and it doesn't give an error. This is fine. If there was a return, so actually not necessarily. So like, for example, if I just wrote int and I wrote here like return num, if I just did that, it wouldn't change anything, right? Because just calling this doesn't actually necessarily do anything. But if I return num, and had an assignment like num equals this, then yes, it would, right? Because now we're actually assigning that change to num. Cool. All right, next question. Yeah, awesome. Right. So it's 11. Not 0, not 1, but let's see, right? Because remember, an array is a reference type, right? It's not a primitive data type. Because this isn't just an int, it's an array of integers. So when we actually call the add 10, what it's doing is it's passing not a copy of this array, it's actually passing the array itself. So when we pass in this array and this array are exactly the same. Like they point to the same place in memory. They're the same thing. So when we go through this loop, right, from 0 up to the length and change everything by adding 10, it's actually changing what's in each position. So it's adding 10 to every position. So it adds 1 plus 10 equals 11. So now in array 0, it's 11 instead of 10. Yeah, sure. Yeah, so this is actually just one of the ways in which we can make an array. There are like, I guess like a few different ways, right? 3. So like we can have like int ar equals new int, and then the next line, for example, like sorry, new int, and then we make this, and we set a size, like we could set 1, and then on the next line we could say like ar sub 0 equals 1. That would be another way of doing the exact same thing. We could also write this, and we could just set that equal to like 1. But what this is doing, this is just another way of writing it, where you just say this is more like a more explicit way of saying it, like, oh, we're making a new integer array and we're putting 1 inside. So it's just a combination of like writing the two different ways, but this also works. It's just another way to write, like making a new array and just putting a 1 inside of it. So all this is saying is it's an array of length 1, or not, it's not saying an array of length 1. It's just saying an array that only contains 1. Yeah, it's just another way of initializing. So like, for example, if I had inside of there, if I put like 3, then it would actually just be like a 3. It would still be a length 1. Or if I could also do like 1 comma 3, and that would be just like length 2, a 1 and a 3. Yeah, cool. Glad to. Okay. Putting 1 inside each index. Oh yeah, so yeah, like I was saying, like its size is just like however many things I actually put here. Cool. All right, so next question. Awesome, Zach, way to get on the leaderboard. Oh, you guys answered pretty fast. Yeah, so it's true. So this is really like kind of a tricky one, right? Because it looks like, oh, we're doing integer division, but we're not, because what's actually happening is we're doing this cast here, casting 36 to a double before we do our division. So what that means is that we're doing 36.0 divided by 5. So this actually acts as a double. So now 7.2 equals bar. Okay. If we were to do something else, if we were to do something like this, it would not be true, right? Because this would just be 7. Because this, if we put parentheses around this, right, it would do the integer division first. But we didn't, so it reads like from left to right. I mean, and parentheses take precedence over division signs. And so it's going to like do the double and it's going to apply to this. And then it's going to divide by 5. Okay. Uh, oh, so yeah, if I did 36 divided by 5 in parentheses here, and I've kept the double here actually, right, it would just be 7.0. And because this would be just go to like this itself, sorry, would be 7, but then the double applying to the 7 would make it 7.0. And also there was another question. Yeah, so double, right? So like double 36 makes it 36.0. Like it turns 36 into 36.0. Okay, cool. Nice job. We're moving up. Wow, someone answered really fast. Oh, yeah, I can see why. Okay, well, I guess this is a freebie. Oh no! Or maybe, oh yes, like 50-50, right? Yeah, so it's false, right? So nice. Yeah, so it's false because like we were just saying, right? Because like what we're doing is first, what this does is it does this first, right? And so because we have the parentheses around it now. So this actually like casts like we cast after we do our integer division because integer division, 36 divided by 5, well, in integers, that's just 7, right? We have no remainder. So we have 7, and then we have our double. So the double applies to the 7. So now it's just 7.0. So var is 7.0. It's not 7.2. Okay, makes sense? Or is that not clear? Like, if it's not clear, then, like, let me know. Okay, so it seems like it's clear. That's good. Oh, John. Yeah, awesome. So, right, it's true. Because here, before we even do our division, right, we have to actually like cast 5, right? Because we have double 5. So it casts 5 to a double. So it's 5.0. So 36 divided by 5.0. If you guys remember, right, whenever we do like division or multiplication, or yeah, in which one of them is or addition or subtraction, or yeah, like any of them, right? Any arithmetic operations in which one of them is a double, it'll like do promotion of the other one to a double as well. So it's going to turn 36 into 36.0. That's what it's actually going to do right before it actually divides. But all we really need to think about it is, oh, one of them is a double, so it's going to perform a double operation, right? It's not going to do integer division, it's going to do regular division. So it's going to give us 7.2. Okay, yep. So then let's move on. If you have questions, like again, just like ask. So cool. Oh, leaderboard stays the same. Yeah. Oh, that's really good. Yeah, because this is a really sneaky problem. So I'm glad someone got it. Because like what it's saying is like this is what A is, right? So okay, that's what A is, right? A is this. So let me just write it that way. Right? This is A. Then we assign B to A. So now B is also pointing to the exact same thing, right? It's the same exact stuff, right? Then we say A equals new int. So when we use the new keyword, that makes a new array. And so it's not pointing to the same place. So now what this is saying is like not only, it doesn't change what both of them point to because we actually use the new keyword. So when we use the new keyword, it means that we actually change only what A points to. B still points to the same thing. So now only A changes and now A points to this. So we set A3 equal to 2. So when we set A3 equal to 2, well, this is A3, so this is 2. But see, B points to the same thing as before. We never changed it, right? So this is what B is still. So then we just print out what B is, and it's just 11, 22, 10, and 8. We never changed it. Okay. Awesome. 3 in a row. Making a comeback from first place. I'm not really sure it's a comeback, but like, okay. What? Okay. Yeah, I guess we're just gonna like, yeah, we're gonna skip this one, I guess. I don't know what happened. But yeah, we're gonna skip it. Yep. All right, so I'm back. I'm so sorry, guys. I don't know. I lost my internet connection for a minute. So yeah, but I think I'm back, right? Yeah. Okay, so back to the game, I guess. Thank you. Okay. Yeah, sorry about to come back, but you know, I came back. Okay. Oh, really? Oh, okay. Then yeah. Oh, okay. Yeah, I couldn't see the problem either. I don't think for question 18. So I don't know what really happened there, but it's in the presentation. So we'll go back to like what the actual problem was later, I guess. Yeah. So this, as for this problem though, yeah. Oh, but thanks for telling me about that. Appreciate it. Yeah. As for this problem, right? So this prints false and true. So why is that? Does anyone know? Can anyone tell me why this is false? Right. Yeah. Exactly. Right. Perfect. That's exactly right. Mm-hmm. Yep. Exactly. Yeah. Right. So when we try and compare with equals equals, right, it's going to try and compare like the reference of them or like where they exist in memory, right? If it's not using primitives, right, it's using arrays or something, it's going to try and say, oh, are they the same? Like they have the same hash codes, they exist in the same place in memory. And they don't, because this one we set equal to this, right, array 1, and then for array 2 we use the new keyword. So when we use the new keyword, right, like it's saying, okay, this exists in some other block of memory. Like there's somewhere in memory where array 1 is, and somewhere in memory where array 2 is, and they're different places. So this is not going to be true. But how about the second? Why is this true? Right, yeah, exactly, right. You're basically like comparing what's inside the indices, right? Yeah. Right. Or it's comparing like the values at each index, right? Because in array 2, we fill up array 2 with 1, 2, 3, 4, 5. So what this is going to do is going to make this is what array 2 is now, and array 1 is this. So when we actually do this, we're saying, okay, for each index, compare. If they're not the same, then we set is the same to false. But every single index, the values are the same, right? The value of every index is the same. So we never actually set is the same to false. So it remains true. So it's still true at the end. Cool. Yeah. Thanks. Oh, nice job, Maya. Moving up to the leaderboard. Okay. I don't think that's right. I'm not really sure what happened, but anyway, yeah, there's no way that's right, unless I'm going crazy. Yeah, so I don't know. I think, yeah, something's wrong there. Okay, but anyway, the idea was supposed to be, right, for array variable, this array, right, it's going to go through the loop and it's going to say, okay, like this is represented by rows and columns in this manner, right? It's 1, 2, 3, 4. That's our first row. 4, 5, 6, 7 is our second row. 7, 8, 9, 10. And then 10, 11, 12, 13. And what this does is it goes I less than 3 and j less than 3. So it just basically like adds everything in this array, right? Because every row goes up to like, oh, sorry, it goes up to position 2, not 3. Huh. So I'm wrong. Yeah, but yeah, it goes up to position 2. So it's going to say, okay, like it's only going to check like up to position 2 for each row. And it's only going to check like up to the second row. And this is the second row, and this is the second column. So it's going to add everything inside of this. And then at the end, it's going to divide by 2, but it's going to do integer division. I have no idea why it would be 31, 0, 22. Yeah, I don't know. But anyway, this is kind of the idea of what we would do, right? I think you have an online calculator. I think so. Pretty sure. If you don't, like if you did on the first one, then you definitely do on this one. Yeah. Okay, cool. Yeah, okay, that's good. Awesome. Yeah, so that's a poll, right? Yeah, it's just like you guys got, right? So For a pull, you go from the remote, right? And you download it to your computer. For a push, it's the other way around, right? It's from your computer to the remote. For commit, you're like staging it so then you can push. Updates, nothing. Yeah, sure. So like these would be the main three, I guess. Would be commit, push, and pull. And then there's also clone, which init initializes a repository because it just creates it on your computer. Clone actually like makes a copy. The first time you can make a copy of the one that's online or the remote onto your computer. But I can go over, I guess, in more detail. Wow. Okay. Oh, yeah, sorry. Right, but yeah, this would be the answer because so okay, a push operation doesn't pull changes made to the remote repository. It pushes changes to the remote repository because the remote repository is what's online. It's like GitHub, right? That's an example of a remote repository. Your local repository is what's on your computer. So it's the like Git repo on your computer. Then there's also one that's online. So what we do is we like pull goes in this direction, right? Pull, we download or we pull changes to the remote, from the remote to ours. And we push to the remote repository. We don't pull changes because that's what a pull does. Commits are local until they're pushed, and that's totally true because a commit, what it's basically saying is like we have this code right on our computer, on our local repository. It's just on our computer, and then we push it. We don't push it. Sorry, we commit it. So what a commit does is basically like updating the local repository, which you have to do before you even push it. So it's like just updating our local repository with the code changes we made. And a commit is used to save changes to the local repository. Right, that's exactly the same, right? We're just like saving changes to our local, like we haven't pushed yet because a push is what makes it actually go to the remote. And a clone operation makes a copy of a remote repository locally. And that's true because the online repository, right, the remote one, has some code or whatever, right, has our repository. And then we want to make our own local one, right? We want to make this local thing. So we would do that. One way we can do it is just by cloning. So it just makes a copy onto the local repository from the remote. Hopefully that wasn't too confusing. Oh, yeah, okay. So the difference is that cloning is what you do the very first time. Polling is if you want to like get an update or a change. So poll is just like if it basically like if you have this online repository, right, or this remote repository, and you want to make your own, right, and you want to be able to like change what was originally there. If you don't have the repository on your computer yet, you can clone it. It just makes a copy of it, right? And now it's on your computer. Okay. But then let's say that like, I don't know, Bob over here decides he wants to change this. He wants to make it better. So maybe now it's bigger, right? So now this I'm gonna make like the circle bigger. So now what's in the remote repository has a change to it. So what you have is no longer the same, right? Because this is improved. Since this is the one has improved since our last, since we cloned it. So if we want to get the changes, we have to pull. So we pull and we get all the changes that are made to the remote. So that's what a pull does. It's like the updates or the changes that are made since the very first time you got a copy of it. But the first time you get a copy, you can use clone, which also initializes the repository. So it makes it in the first place. Yeah, awesome. So I think someone actually told me this earlier this semester, but right, so you get a multiple catch blocks for each try block if you want to catch multiple exceptions that might happen. Right? But in this case, the exception that happens specifically is an arithmetic exception, right? The arithmetic exception is a flag that's raised, but the reason for it is because we divided by 0. So this is an arithmetic exception because divide by 0 is an arithmetic exception. So when we go and find our catch block, it's going to go to the first one. It's going to be like, oh yeah, it's this, right? Because it's an arithmetic exception. So it's going to say, okay, it is an arithmetic exception. So we print this, and we don't do this because you can kind of think of them as like switch statements. If we have multiple catch statements, you kind of think of it like switch. So it's only going to do one. Like, yes, this is an exception, right? But specifically, it's an arithmetic exception. So it's going to do this because it's going to see this, right? And it's not going to do this one because we've already done one. Yeah. That would be a general rule, I guess. Like, I don't really use try catch all that often, so I mean, I don't really know rules try catch, but like, yeah, I guess that would make sense for sure. Right, awesome. Yeah, so exactly. There's an exception generator, right? But it's not a number format exception. So we don't do this one, but we do this one because it is an exception. So we just say exception generator. A number format exception. That's a good question. Let me think. I'm actually not sure, but if anyone else knows. Yeah, okay, that makes sense. Yeah, if it'd be like the wrong data type, that makes sense. Like if you're trying to maybe assign an int, like int j equals like 5.2 or something, I think that's what it's for. Yeah, cool. Thanks, Ian. Okay, so do you have to import these exceptions into the class? So I think you do have to like import exception or something. Yeah, if you had to do it for your product, you probably usually have to do it on an exam. Like the first thing is that on an exam, even when we make you write code, like you don't have to write import statements because like I don't expect anyone to remember that. But specifically on this exam, there isn't even a coding question. There's no coding questions, so it's not even an issue at all. You don't have to like worry about imports. Yes, this is from the last module. Yep. And there's other stuff that, a lot of other stuff from like some of the modules that I think are more difficult. You still have to go over, but we'll get to them. So yeah, that's right. Okay. So, okay, this is a tricky one for sure, right? Because notice this is a sorted array. So this is what we want eventually when we use bubble sort. But after 2 passes, that's not quite what we have yet. And why is that? Okay, let's walk through how bubble sort works, right? Well, how bubble sort works is basically you're just gonna keep like comparing elements to each other. So in one pass, you start at the front of the array, right? And what we're gonna say is, okay, if this one is larger than this one, we swap them. And then we keep going, we go all the way to the end of the array. And we have to do that like until the array is sorted. Okay. Right, exactly that. Yep. So what it ends up basically doing is just moving the largest element each time, all the way to the end. But also you have to keep in mind that it'll do that, but sometimes it'll move something else along the way. So if, for example, I had, I don't know, 10, 9, 12, right? The first pass, it will also switch 10 and 9, but then it might also move 12 all the way to the end if 12 is largest. But here, what it's doing is saying, okay, 12 is not larger than 13, but 13 is larger than 5, so I swap them. And then 13 is larger than 9, so I swap them. And then 13 is larger than 0, so I swap them. So then I have 12, 5, 9, 0, 13. And now 12 is larger than 5, so I swap them. And then 12, because I swapped them, right? Now 12 is larger than 9, 12 is larger than 0, 12 is not larger than 13. So I stop. So I go 5, 9, 0, 12, and 13. And yeah, that's what this is. Okay. So that's kind of how bubble sort works. Just keeps moving things. Like you just keep checking this element against the next element. And you keep going until the array is sorted. Okay. All right. Next we'll talk about another sort. Okay, we'll go back to it in a second. Let's do this problem, then we'll go back to the last one. Yeah, awesome. Okay. So, okay, before I talk about this one, I'm just going to talk about the last one, previous one just for a second. Right, yeah, there you go, Hayden. Exactly, yep. So in the last one, remember we had like 5, 9, 0, 12, and 13. And you're entirely right, John, that eventually 9, like on the next pass, 9 would get swapped with 0. But the question said after 2 passes. So you have to stop after 2. And here the same thing is true. We stop after 2 passes. So we haven't sorted the whole thing necessarily. And insertion sort works by first, on the first pass, it's going to check the first 2 elements against each other. And it's going to say, okay. So it's going to say, okay, if this new one is larger, then we switch it. So, okay, a good way to think about this one is you have a sorted portion, like a sorted list, and an unsorted portion. So in this case, our sorted portion in the first place, before we start, we know that one element by itself is always sorted, right? Because 12, if it's a list by itself, right, it's sorted, and there's no questions about it. We can think about it as we have a sorted part and an unsorted part. So next, we have our unsorted part, which is 13, 5, 9, and 0, right? This may not be sorted, but one element by itself is always sorted. So in our first pass, we check the first element of our unsorted portion, and we're going to throw it into this one. So now we have 12, 13 is our sorted portion, or it may be sorted. We haven't actually sorted it yet. And we have 5, 9, 0 as the unsorted part. But now we have to actually sort it. Well, if we're putting something in, we just have to find the right position. So we're going to check 13 against 12. Oh, okay. Well, 13 is larger than 12. So it's already in the right spot, right? So we're good. Now the sorted portion is actually sorted. Next, we have to get that's the first pass. Then the second pass, we're going to get the next element from the unsorted part. So now we have 12, 13, 5. We have to sort it now, right? And the way we're going to sort it is we know the first two are already sorted. So we just have to find the right place for 5. Well, 5 is less than 13. It's less than 12. So we have 5, 12, 13 is our sorted part. And our unsorted part is 9 and 0. But since we only wanted 2 passes and we made 2 passes, this is our whole list. It's just 5, 12, 13, 9, 0. Yeah, for the first pass, right, it would just be 12 and 13. Right. But the whole list, I mean, because insertion sort is on one list. So like if we thought, like we can think about it as the sorted part and unsorted part, but the whole list would still be like 12, 13, 5, 9, 0. Right. So yeah, for one pass, it would just be like, it would be the same as the original array, actually. So does that make sense? With the sorted part, unsorted part, you're like inserting, it's called insertion sort because like you're inserting the next element from the unsorted part into the right position. So it's insertion sort. Okay, yeah. So why did it stop at 12 and 13? Okay, right. Because for insertion sort, the first time through, like before we start, we have one sorted element. After every pass of insertion sort, you're including one other element into the sorted portion. So after the first pass, you have 2 elements in your sorted portion, right? Because we just like put 13 in there, and then we make a pass in which we're actually like finding the right place for 13. In the next iteration, so the next pass of insertion sort, we put the next element of the unsorted part into the correct position. So the first iteration, or the first pass, we have 2 elements. And the second pass, we have 3 elements, right? Because we just need to find the right spot for the elements. That's what basically each pass is finding the right spot for the next thing. So the first pass, we're finding the right spot for 13. And in the second pass, we're finding the right spot for 5. In everything on the left of 5, we have to find the right spot. Cool. Right. Awesome. The next question then, because I realize now we still have like a fair amount to get to, so I'll try and hurry a little bit at least with this stuff. Well, I guess not, but okay. I guess stuff might be kind of difficult. Awesome. Yeah, I like this unit too. Yeah, so this is absolutely a trick question, but it's O1. So like, yeah, just be careful. Like, I know it doesn't look like O1, but it's a trick question because if you look closely, you'll see that here we made a new array of which is 100 by 100. So we have a fixed size, right? So when we actually loop through our array length, we know we're looping exactly 100 times. So it's not variable at all. It's fixed at 100. So we know we're going to make exactly 100 passes of this loop, which is just O1, right? Because it's O of 100, which is equal to O of 1, right? Because this operation itself only takes like O1 time. Like that's just like something you could do immediately. You don't have to loop over anything. And this will make 100 passes, but that's just O1. So yeah, a little bit tricky, or a lot tricky, but yeah. Make sense? And also, the other thing to notice is that even if this was like n by n, this isn't n squared, because we only have one loop in which we're just looping over the number of rows. And each time we just get the 0 element of the column. So even if this were m by n, this would only be O(n) time. Oh, yeah, I also agree with that. So yeah, some good opinions, Aiden. Yeah, so for this one, it's n by m, right? Because in the outer loop, right, we make n passes. So n. The inner loop, every time we make one pass of this, we make m passes of this, right? So what we're saying is we have m, and we're going to do this one, outer one, n times. And for every one of those n, we're doing m of these. So basically, the first time through the outer one, we're doing m. Second time through, we're doing m. Like, second time through this one, we're doing m inner ones, right? And the thing is that we have to sum, this sum is going to be n m's, right? So we're going to do this, and this is going to be length n. But that's just the same as saying like n times n, m, right? Because we're doing this inner thing n times. And this inner thing, each one is m. So we have m plus m plus m n times, and that's just n times m. So it's O of n times. Okay. Cool. Yeah, so exactly right. It's n plus m, right? Because these are done separately. So we do this one first, and it's just n time, right? O of n. And then we do and then once we're done with this, then we start this one and do this one, independent of the first one. And that's O of n. So what we have is just O(n) plus m, right? Cool. Nice job. Okay, cool. So right, this is 01. So this one's also a little bit tricky, right? What we have here is we have our for loop, right, over the other one, and that's 100, right? So even though we have 2 for loops, it doesn't matter because this is 100. This is 100, right? So we're going 100, and each of the 100, we're going to be going for some number, but j is less than I. Well, I is a constant number because it's always going to be somewhere between 0 and 100, right? Or yeah, so then we just, this is constant, and this one's constant. So the total number is still going to be constant. So O of some constant, that's just O1. So that's why we get O1. Okay. Awesome. Yeah, this is O of n squared. So this one might seem kind of weird, right? Like, why is this one O n squared, right? It kind of looks like we have 2 loops, right? So I mean, that part is good, right? We have 2 loops. I is less than n, then j is less than I. So what's that going to look like? Well, that means the first time through, we have this one's going to iterate 0 times, or like 1. The first time, this one's going to go 0 times. The second time, this one's going to go 1 time. So it's not like this is all the way up to n. It's only up to I. So why is that n squared? Well, actually, this is kind of fun. So what this is basically saying is that we have our sum here of, we're going up to n, right? And so, but then this one, we're going up to I. So basically what this is saying is that the first time through, we're going 0 times. The next time through is we're going 1 time, then 2 times, then 3 times, all the way up to n. I mean, we're just going to say n because it doesn't really matter. Like j is less than I, so it really be n minus 1. But like for simplicity, I'm just going to write n. So what does that mean? Basically, we have our sum here, right? Sum where n equals, or let's just do index. So like we have a sum for k equals 0 up to n, right? Where we just have k, right? So we're summing over all of these. So why is this going to be n squared? Well, we can kind of think of it like this, right? We have 0, we have 1, we have 2, dot, 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 and then we have comma, n minus 2, n minus 1, n. So we can pair them, right? So we can like pair these up. So we have like our 1 goes with our n minus 1. Our n goes with our 0. Well, actually, I guess like we would end up pairing n with 1. But okay, anyway, like because this 0 term just is 0. So what we'd have to do, what we would end up having to do, like if it's odd, for example, would be we pair like 1 with n, 2 with n minus 1, 3 with n minus 2. So we're pairing them, right? And how many pairs are we going to have? We're going to have n over 2 pairs, right? And each of those pairs sums to n plus 1, right? Because n minus 1 plus 2 and 1 plus n. So all of those pairs sum to n plus 1. We have n over 2 pairs. So that's the same as n squared plus n over 2. So if we have O of n squared plus n over 2, that's the same as just saying O of n squared. So I know it's like a little bit like tricky, but yeah, that's why it's O of n squared. Even though, it's just some fun. Okay, last question, and then we can move on to the rest of the PowerPoint where we have some other stuff that like is pretty important. So I definitely want to get to that. I'm not sure if they're curved, but I know we have like other extra credit we're getting. So hopefully that's good. Oh, sorry, I just remembered. Yeah, I should have said something earlier. This should be a 1, but like it's O of n log m. So this is kind of tricky, right? If you guys want, I can like explain this one too, but like since we don't have a bunch of time, like I'll explain like why it's O of n log m, but like I won't like unless you guys want me to, I won't really explain like all the details why. This actually goes to O of log m. But if you guys want to know, I can tell you. But yeah, this is like a loop, right? This goes n times. But this one, if we start at 1, right, and this one, we're going to be going j multiplied by 2. So we're having it go up to m. But every time we're halving, or like cutting in half, the distance between 1 and m, because we're multiplying by 2 each time, right? So we're getting closer and closer. But it's like not a sum, like not an arithmetic, it's going to be like geometric, right? So this ends up going to log m. And so we have n, so we have log m, but we have n times, right? We keep summing like log m plus log m plus log m n times, right? That's n of them. So then we have n log m. Okay. So any questions about that? Okay. If not, we'll go to the last, like we'll show the results. And then there's like some really important stuff I still want to get to. So like some of the sections we didn't even bother going over. Oh yeah, good job, Andrew. Good job, Maya. Good job, Hayden. Oh, sorry, I didn't mean to spell it. Awesome. Good job to the runners up. Okay. Awesome. Yeah. So good job to everyone. But now we're going to go over the rest of the presentation because there's like some important stuff from like some sections we didn't even bother covering in there that I think are like really important. So we'll get to those now. Yeah, these slides are really nice. That's a good picture of a shark. Okay, so there's some stuff I want to specifically go over. Oh yeah, so number conversion. So we can go over this like, I guess we kind of went over it a little bit, but I want to make sure to get to this other stuff. Yeah, let's go with classes. So this is something like modules 6 and 7 we didn't have time for, and I really think those are important. So let's see those. Slideshow. Okay. So yeah, so for classes, so does anyone know what we would do if we want it to be accessed only within the gift card class? Like what would these 3 be, do you guys think? Private, right? First one, private. Exactly. Yep. Okay. So almost, yeah. So okay, yeah, good thing, right? So this one is private. Absolutely. Yep. Yeah. Awesome. Great. Okay, so the last one. Okay, so let's talk about these next two. These next two are a little bit tricky, right? So if we want it to be accessed by any class that uses a gift card object, what that would be is like it's saying, okay, anywhere where a gift card object is, we can just use the methods that come with it. And so for that, it would just be public, because for public just means you can access it anywhere where you have an object of that type. So anywhere there's a gift card, we can use any public methods. So here, this is public. This one's private, as we said. This one is actually protected. And the difference between default and protected is default is just anywhere inside of the package. So basically, you can kind of sort of think of default as almost public, because anytime you're going to be using public, you're probably going to be using, or anytime you use default, would probably public would be fine. But this is protected because anytime you can only access it by a class that derives from gift card, it's protected. So if I had like public class, I don't know, some company's gift card, company gift card, right? And then I said extends gift card, then I could, and let's say this was protected, then I would still, in this class, because it extends gift card, I would have access to this balance variable. So that's what protected means. So this one's protected. And if we look at it, right? So private, protected, and public. Okay. So then the next one, okay, so yeah. For this one, what is the return type of a getter method for the switched on variable? And what would be the setter method's return type? Yeah, that's exactly right. Nice job, Morgan. Yeah, setter is void. You don't return anything into setter because we're just setting it. So in this case, what would be the getter return for switched on? Awesome. Yeah, right, exactly. Boolean, because we want to return the type that it is, right? It's a Boolean. So we wanted to like do get is switched on or something like that. Then yeah, we would have to have a Boolean it returns. And for setter, right, set switched on, you're exactly right. It's void. You were just setting. Okay. Oh yeah, sure, we can go back. Yeah, setter's taking input. That's right. So like, okay, if I did like set switched on, right? I would take in like Boolean on, right? But this wouldn't return anything. It would have to be void, which means it returns nothing. It just sets. Yeah, exactly right. You have to set this, but you don't actually return anything. It's still void because it doesn't return anything. It just sets, right? There's nothing to return. Yeah, there's nothing to return. It just sets the variable. But the one that takes parameters, you're right, is a setter. A getter wouldn't take parameters. Okay, so for this one, I think this is a good question. So you have any ideas what it might be? Okay. Okay. All right. So yeah, I'm seeing some answers, and that's good. But yeah, so like you guys are like completely on the right track by thinking B, because like that was my first thought too when I saw this. But actually, Hendrik, you're right, because this is like a trick question. So yes, it is null and zero, which seems really weird, right? But why could that be? How could that be? So we make a new student, right, named Emma. So what we're doing is we're saying, okay, right, exactly, yeah, we didn't use this dot, exactly, that's exactly right, Hendrik. Yeah, we didn't use this dot name or this dot grade. So when we make a new student, Emma, what it's really doing is going in here, right, into the constructor, setting name equal to name. But because we didn't specify that it's this dot name, it's just saying name equals name. But the default, if you don't use this dot, is whatever has like the smaller scope. In this case, the smallest scope is the thing that's just passed into the method. So that's just going to be name. It's going to try and set this one in particular, when you just use name, it's going to set name to name. But that doesn't do anything for this, right? It doesn't change this. And the same thing for grade. It's going to be referring to this grade if you don't use this dot. So it's just grade equals grade. So it doesn't actually change the grade. So these have the same values they did originally. Never changed them. How about this one? So yeah, I guess there's a lot going on here, but okay. All right. Let's try this out. Let's look through the code. Okay, so I'm seeing a couple answers. Yeah. All right, so I'll go ahead and actually show the answer, and then we can walk through it if you guys want. So yeah, it's 2. So this one's also a little bit tricky, but like those are still some good answers, and I can see how you guys got all of them. Like whether it's 2 or 3, I completely get it. So let's see why it's 2. Yeah, that's right. Yeah. It's all right. Robert is a student, so it says new student Robert. So what we're doing here is we're actually increasing our student count. So student count now is 1. And it's static. That's what's important here. It's a static variable. So that means across all classes, it exists. We say Paul equals new student Paul. Okay, so now it's 2. Person will equals new person will. So we're going to actually just go into the only constructor we have to worry about here. Right, exactly, right. This person will is a new person. So it's a new person. So it's going to go into the person constructor, right? It doesn't actually go into the student constructor. So because that's true, it never actually increments student count. So because it doesn't do that, we still have 2. And this last one, student Santos equals Robert, well, that creates it doesn't create a new student, right? It just creates another reference for the same student. Like it's just making another name for the data that's here, right? Just like how if you like set an array equal to another array, it doesn't make a new array. It just like creates another reference for it, like another variable for it. So here, Santos is still the same as Robert. We don't actually call the constructor because they never use the new keyword. So when we print Paul.get student count, it's still 2. Well, actually, we have to do to get student count, which we can see returns the student count, which is in this case 2. Right, increments for every student because we have student count plus plus inside of our student constructor. So every time we make a new student, we go into this constructor, we increment this count. But like if instead we had like, I don't know, student count plus equals 2, then it would increase the student count by 2 each time instead of by 1. So you have to make sure you actually look at what it's incrementing by, but yeah. Okay. That's right. Yeah. So sorry, I was gonna go back one more time. Sorry. Yeah, like if I had not put super name, it would try and call just super, and that doesn't exist. So it would try and call the parent constructor by default. No, you're good. Don't worry. Okay, actually this one's like gonna take a minute. So I'm just gonna like I guess go over it, right? Or no, and these are option choices. So never. Oh yeah, I can totally do that. Okay, so I'm just getting some answers for D, and I think, if I remember correctly, Yeah, that's right. Cool. Right. Because we're making a new car, right? So it goes into the constructor of the car class. Right. And it doesn't have one written explicitly, so the default is just the default constructor, which inside of it calls the default constructor vehicle because it extends vehicle. But vehicle doesn't have one written either, so it just calls default constructor. Right. Super keyword. So it in this case is actually necessary. So let's look. So we call c.move. So here we go into the move method and we say, oh, super.move. So the reason why it's necessary is because we didn't put it, this move would just refer to this one. So it would keep calling itself over and over. It would never stop. So we have to write super dot because we have to like differentiate between the one in the parent class and the one in the child class. Because if the method exists, right, if the method only exists in like the parent, then yeah, we don't have to write it. But if it exists in both, then we have to find some way to differentiate. We do that with the super keyword. But we wanted to like say it's in this class, not the parent, we like this dot. But we want super dot here because we want the parent. Right? So use super dot move. So it goes here first and prints vehicle. And then after that, it prints car. Oh, sorry. Yeah, these are, oh, I guess, hold on. These are not constructors, but it doesn't matter. We can still use a super keyword. Super dot just means like the method that exists in the parent class. But these aren't, this isn't even a constructor, it's just a method. And that's perfectly fine. Like you can use super dot anywhere as long as like this is a method that exists in the parent class. Okay. Oh yeah, new car, right. So you're right. There is no constructor written, which means it calls the default constructor. Oh, it doesn't. Sorry, it doesn't. I was looking at the next line. Yeah, right. It calls the default one, right? Exactly. Or the implicit one. That's right. So, yes, that's exactly right. Okay. So for this one, which of the above compile? Yeah. So I know a lot of you haven't had too much time to think, but like I'm just gonna keep going because we're kind of running low. So yeah, that's right. It's the first two, and the reason for that is because when we actually check if it can compile, we have to read like from right to left. We have to say, okay, is shark an animal? So does shark extend from animal? Maybe not directly, just does it extend from, and it does, right? So this is okay. We can do this because shark extends from animal. So we go from right to left, shark is an animal. Here, baby shark to object. Well, object, every object you make derives from object. Everything. So when we do this, we read from right to left. Baby shark does derive from object, like it, because basically what's implicit here is it doesn't have to be written, but class animal extends object because every object extends from object. So when we do this, it says, oh, it's basically saying baby shark is an object. Well, it is. It extends from shark, shark extends from animal, and animal extends from object. So baby shark is an object. So this is also good. This one's not good because animal is not a baby shark. Because a baby shark is an animal, not the other way around. And this is also no good because baby shark isn't a great white. Because like a baby shark extends from shark and a great white extends from shark, but they aren't the same. And like if we were to draw out like parent, the parent is great white, or no, the parent is shark, right? And then great white is here, and baby shark is here. But like great white or like shark does not extend from great white, right? They may share a common ancestor, but they're not like extending from each other. Like you can't go like right to left. You can't be like, oh, baby shark is a great white. It's not. A baby shark is a shark, and it's an animal, and it's an object, but it's not a grape. And it's also a baby shark. Okay. If you guys have questions about that, like ask. Oh, and also I just remembered I said I was going to go back to the question you had, Morgan. I think it was Morgan. Yeah, difference between accessing static and non-static. Yeah. So a static variable is one that exists across all instances of objects. Like anything that has to do with that class it exists in. It's just a class variable. That's what a static variable is. It just belongs to the class. A non-static variable thing belongs to an object, which is an instance of the class. So if I have, for example, this, if I have like a shark class, right? And I have some, I don't know, if I have some static variable, right? Static int number of sharks or something, num sharks. Then what that means is this exists and it's exactly the same variable. Like it has the same value across all sharks I might create. Like this because it belongs to the class. It doesn't belong to an object. But if I made like int name, right? Or no, not int name, string name, sorry. Then that would only refer to one specific shark. So like every time I create a new shark, I might give it a name. And this name only belongs to that one object. So if I make a shark like, I don't know, shark A equals new shark, and I give it a name like Dave or something, right? Then that Dave is only the name of shark A. It's not the name of every shark. But this num sharks is a variable that belongs to every single object from that class. Like if I made another shark B, like it would have a different name because this string name isn't static. So this B would be a different name for B maybe, or it would be a different. But this num sharks would be the same. It would exist in both. Like this is shared across all instances of the class, like all objects, but non-static only belong to a specific object. A non-static method, that is exactly right. Yes. 100%. A non-static method. Yep. And that will give you an error. That's entirely right. Cool. Okay. Yeah. We're running a little low on time. That's okay. And I don't mean, so when I said that, I didn't mean like it as don't ask questions. Like, please ask questions if you're confused. Like, I just wanted to make sure I also had time for questions at the end. That was all I meant. So I guess I'll just run through these because of that. I want to make sure we have time for questions. So, right. So sedan S1 equals new car. Like we said before, right? A car is not a sedan, right? So this is not good. No good, because a car is not a sedan. A sedan is a car, but we go from right to left, and so that's not good because car is not a sedan, right? So no good. The next one, vehicle equals new sedan. A sedan is a vehicle, right? Because a sedan is a car, which is a vehicle. So this line is okay, right? What about the next line? Well, car C1 equals car V1. Well, we can totally cast V1 to a car because a V1 is a car. It's just also a sedan, also a vehicle. So if we wanted to cast it to a car, that's good. That's fine. We can do that because like it is a car. So this is also okay. Object O1 equals new car. A car is an object, right? So this is also fine. And then the next one, a sedan is a car. So that line is also good. But then we have to look at the next line is, well, we can cast C2 to a sedan because it is a sedan at runtime, right? So we can totally cast it to a sedan. And when we do that, we can set C2, S2 equal to C2. So this one was also fine. How about the next one? Well, vehicle V2 is a new car. A car is a vehicle. So that's also okay. So all of them are okay except the first one. And none of the above is not also not. Okay. Yeah, I said at runtime. That's right. Because what's happening is like at compile time, you have the type that's on the left. The type that's on the left is whatever is given at compile time. The type that is on the right is whatever you have at runtime. Compile time is on the left and runtime is on the right. Right. Like if, for example, if I just wrote like car C1 equals V1, that would not work because if I don't cast here, it's not going to work. And the reason why it's not going to work is because at compile time, it won't compile because it's going to say I can't set a car equal to a vehicle because here a vehicle is not a car. A car is a vehicle though, because it doesn't know that V1 is actually a sedan because I haven't cast it. Right. We'll see like another example of that. In a minute, yeah. Yeah, you could, right, exactly that. Yep, you can always cast a child class to the parent. Yep, or to itself. But yes, yeah, absolutely. Can you downcast like the other direction? No. And the reason why you can't do that is because, like, for example, if I have a vehicle, right? Let's say I have a vehicle, right? And I want to cast that to a car. Well, the problem is not every vehicle is a car. Like my vehicle, maybe I'm super rich and my vehicle is an airplane. Or maybe it's a really bad airplane, so I'm not actually that rich. But maybe I have an airplane. Then I can't cast that to a car. So you can't always down. You can't ever downcast. Yeah. Yeah. And as for this one, right. So this one, yeah, that's right. Okay, cool. Exactly, because we make a new, yeah. So, sort of. Yeah, actually, it is. It totally is. That's right. That's good. Good point. Right. Because the type at compile time of doggo is animal, but the type at runtime is dog. So what that means is that it compiles fine because the dog is an animal. So that's perfectly okay. But at compile time, like it's fine, it passes, right? But then because it compiles also, we have to point out because doggo.print is okay because the print method is inside of animal class as well. So even though it thinks doggo is an animal, that's fine because animal has the print method. But if we then go to the runtime, when we actually run it, we're going to say, okay, doggo is a dog because at runtime, we use the type that's on the right. So at runtime, it's going to say it's a dog. So when it does doggo.print at runtime, which is actually when the code runs, it's going to say, oh, look, we're going to go to this print statement that takes no arguments in the dog class. And it's going to do this one because at runtime, it's doggo's a dog, not just an animal. It's going to print dog printed. Oh yeah, so two conditions we had to check. One is we had to make sure at compile time that we actually compile. And the reason why is if it doesn't compile, then I mean, it can't even get to runtime. So the first thing that it does is it says, okay, is dog an animal? Oh, it is, right? Like it will compile, this line will compile because the dog is an animal. We go from right to left. Dog is an animal. The second condition we had to check was, they had to check that the second line also compiled. In order to do that, we had to make sure that doggo had a print method. Well, because at compile time, we think that doggo is an animal, right? We don't know that it's a dog yet, because at compile time, we only know what's on the left. Then we have to make sure that animals have this method, and animals do have this method, so it compiles. And then after that, we can actually do what it would be if it were a dog, because dog's on the right, so we can run it. Right, exactly, it needs override. Yep, that's right. Cool. Okay. Yeah, so if you're not, right, yeah, so, okay, if I, for example, let's say I didn't have this print statement here, I don't know, something like that, right? Then this wouldn't compile because it wouldn't have that. So in order to make this compile, if I didn't have this print statement, what I need to do is I need to cast this, right? Which I can do. I can cast it to a dog because at runtime it will work. It'll be fine because it's actually a dog. So at runtime, I would have to do, like, to make it work at compile time, like it'll work at runtime, but to make it work at compile time, I have to cast this doggo to a dog in order to print it. And then this would also be okay, even if this print statement isn't here. So next question. Okay, so this one is a doozy. I'll walk through this one, I guess, with you guys. I just mean it's a doozy. It has a lot of parts. That's all I mean. Actually, since time is almost up, what I want to do first, actually, so here's what I'm going to do instead. I will go through the rest of these. Like I'm recording this, so I'll put the recording online. But for anyone who has to go, as there are only 6 people left, I just want to make sure that I get to all your questions. So I'm going to stop and let you guys ask questions. And even if everyone leaves, I'll finish the video. I mean, hopefully some of you stay, but I want to make sure I get to your questions before you have to go. So if you guys have questions about like anything that you want to know about, like ask those now, and then I'll go back to the rest of the review in a minute. Yes, that's right. What's actually happening is it's going to go to the default constructor at runtime, right? It goes to the default constructor of the dog class, right? Because at runtime it's a dog. But because dog extends from animal, it's going to go into the dog class's implicit default constructor, and then it's the very first thing it's going to do is actually going to it's going to go to the animal constructor first. So inside of that constructor. So like, yeah, it's going to make a dog, and inside of making the dog, it's going to make an animal. But yeah, it's going to call no argument constructor. Has no effect on the output, that's right, because we haven't even written them, so it's just like nothing happened, yeah. Are there any other topics that like, I don't know, are tricky or like you guys want to go over? I mean, if not, we can like finish this because I think this is like important. This inheritance stuff is like tricky, so we can finish that up. But I just want to make sure, like, are there any other topics anyone wants to go over? How many more questions? Not a lot. To be honest, it's, I guess, just like, oh, well, one, but then also I wanted to go quickly over binary search. So 1 plus binary search. So I guess, well, yeah, if you guys don't have questions, I'll just go over this one quickly, and then we can go on to binary search. So if we do this, right, if we call a.print type, A is a person, right? So when we do a.print type, like that's fine. It's going to compile just fine. It's going to print normal person. So the first one prints normal person. Okay? Good. What's the next one? what if we try and cast A to a student? What do you guys think is going to happen? It's going to be good or bad? Bad, right, exactly. Because not every person, A is a person, right? And not every person is a student. Even at run, like it's going to fail at runtime. Because the thing is that it's not going to fail at compile time because it's going to say, okay, yeah, A is a student. Okay, you're making A a student, and student has a print major method. All right, so that's good, right? That's going to work fine. So it's going to compile, but then at runtime, we have a problem. And that problem is that here, A can't be casted to a student because A is not a student. It's just a person, right? We never said that A was a student anywhere. So we can't do this because at runtime, it's going to say, oh, wait, I know you tried to cast A to a student, but like A is not a student. So we can't actually cast it. So it's going to fail at runtime. It's going to be an error. Okay. So what about this one? B.print type. Actually, what do you guys think this one's going to print? I think this one's an interesting one. What do you guys think it's going to print? Student. Yeah, that is right. Yep, exactly. It's exactly right. Yeah, because what it's going to do, that's exactly, yep, exactly right. Like it's going to, the only reason why it compiles is because print type also exists in the person class, right? Because all it knows at compile time is, oh, it compiles because this person, like the person, has a print type. So it compiles just fine. So we get past compiling time, we get to runtime. And so it checks the type on the right, which is a student. So it goes into the print type method of the student class. So it prints student. Exactly. What about this line? B.print major. Yeah, good. Yeah. So like all of you had some good thinking. And right. Yeah. So yeah, awesome. Yeah, that's exactly right. Right. So like it's going to give an error, and the reason why it's going to give an error, right, is kind of like you guys were saying, is that here it won't compile because we try and do a B.print major, but on the left we look at the compile type of B, and B is a person. Well, we notice we look inside the person class, and inside the person class there is no print major method. So it's going to say, wait a second, B is just a person. It's not a student. It doesn't know that the runtime. It only knows the compile time type. So it's going to say there's no print major method, and so it's not there. So I can't call it. So it won't compile. So in order to fix it, we would have to cast B to a student, right? We'd have to like student B, and we can do that because B is actually a student. Like, right? B is actually a student, so we could cast it. But oh, I guess I just gave away the next one. But anyway, sorry about that. Yeah, so this one I guess I just gave away. Like, why does this one compiles? Because now B is actually a student, right? And so we can actually cast it because it actually is a student. So when you do .print major, like a student has that method, and it successfully casts B to a student. So then it actually prints the major of B, which is Peterson. Yes, yes, it's a student at compile time, right? And that's the difference between this one and this one. That's why this one is okay and this one's not okay. Both compile, but only this one works at runtime. Okay. So the next one would be like C.print type. So what do you guys think happens there? Oh yeah, the previous one would print comp sci. Yep, that's exactly right. So how about this one? One person. Well, let's look at what we think will happen. So that's a good thought. Let's look. Yeah. It's okay. Yeah. So notice C is okay. C is an object on the left, right, and a student on the right. So what's the compile time type of C? Is object, right? Compile time is object. Run time is student, right? So now we look at print type, and we have to say, okay, first we have to go through the compile time, and we have to make sure it actually compiles. Just to see if it compiles, we have to say, okay, does C have the print type method? Well, C at compile time is an object. So we have to say, okay, does an object have a print type method? And the answer is no, it doesn't, right? Because object doesn't have any methods in it. Like, yeah, like an object is just an object. It doesn't have any methods. So it won't compile because if we were to get to runtime, like that would be right. But we don't get to runtime, we only get to compile time. And in compile time, it's of type object, not of type student or person. It doesn't even have this method. So it's not going to run. That's okay. Those are some good thoughts. So this one's going to give an error. Okay. What about the next one? What do you guys think? Yes, compile is what you do before you run. That's right. You have to check compile first. If it compiles, then you have to figure out if it runs. And if it runs, what does it do? So for this one, well, let's look. What's the compile time type of C? Compile time is, yeah, you're entirely right. Yeah, it's the same problem. Good thinking, right? Because the compile time type of C is object still. And an object does not have a print major method. So this still has the same error as before, where it's not even going to compile because C is an object and objects don't have that method. So it won't even compile. Okay, well, what if now we were to cast C to person? What is this going to print? Yeah, okay, so let's look. Does it compile? Let's see, C at right. So at compile time, right, it's an object, but notice we cast it to a person. So like you said, right, we cast C to a person. So because we can kind of think of it like it's a compile time of person, and person has a print type method. So compile's fine, so we're good. Now we have to check the runtime type. The runtime type is student. So a student, so we do now C is a student, and when we print the type of a student, it prints student. So student it is. So yeah, nice, exactly that. Okay. So what about if we do this? What if we cast C to a student instead? Will it change anything or not? Oh, that's okay. Sure. Yeah. So Morgan, exactly right. It's the same thing, right? It's still student, exactly. Because C is a student, so we can totally do that, right? Like we can cast it to a student. We don't necessarily have to cast it to a person. Oh, yeah. Okay. And as for your questions, Zane, let me see. What if it wasn't print type? Like what? Okay. So we're going to get to that right here, actually. So let's look at that. What if it's print major instead? Right? So this, I guess this question is an example. I think this is what kind of what you're getting at. Like, what if it's something like this? Where anyway, yeah. Okay, cool. Yeah. So for this one, let's see. Well, okay, let's walk through it, right? So we have to have our compile time type. The compile time type of C is object, right? But it's okay.